So what I've done here is I've created a video using a very simple model made of cardboard. The cardboard mimics the implant, and I've created two slots within the cardboard that are angled to mimic the angled compression screw slots of the implants. And I will try to demonstrate how such an implant moves. Now, first of all, what I've done is I've pinned the cardboard down using a pin, and then I've rotated the cardboard about this pin, um, which shows that, as we would intuitively think, that if that was the case, the cardboard would move circularly. And here I'm using a pencil to draw this trajectory, uh, not to prove that it's a circular trajectory, but to compare it with what is going to happen next. So we've done that. We've shown that this is how the trajectory would look like if the implant was pinned down, for example, by using a locking screw instead of a compression slot, compression screw within a compression slot. Now I'm putting the pin within the slot just to show that now I can translate and rotate the cardboard. So the cardboard can now move in different directions. And what I want to show here now is how can we move the cardboard while keeping both screws within the slots. I've created a dot here with a pencil that mimics the position of the screw if a screw is placed in this slot. Now you can understand that as the implant moves around the screws, about the screws should keep remaining in the center of these slots. And I want to show how I can move the cardboard so this can happen. And this is how this happens actually. You can see that there is a way that I can move the cardboard so that both screws stay within the slots. And now I'm using screws so that I free up my hands to demonstrate a few more things. Right, this is how it would move. And I want to draw that movement, this trajectory, and I'm using a very small hole and a pencil to draw the movement while the cardboard moves. And voila, this is it. This is the trajectory of the plate motion while this pivoting, this rotating of the implant happens. Now, one would say, all right, that's what happens down here, but what about up here or up here? Because that's not where compression happens. Compression happens a little bit more proximally, and we could imagine that the osteotomy side would be exactly, approximately there. So, yes, the trajectory here will be different actually. And that means that we may see compression in that direction. But before we go ahead of ourselves, we need to remember that we said that compression doesn't always happen in the direction of movement. So we're going to look into it a little bit further during the next video. Now, another thing I want to highlight from this video is that it doesn't really matter how we grab and move the cardboard and hence the implant. Whatever we do, wherever we grab it from and however we try to move it, it will have to follow one single path. And that's the path we drew before. It can't move cranially and then distally. It is one single path regardless of how we try to move it. That's also something very interesting that will be useful for the next video.